Okay, what we want to look at in this problem we're going to examine today, we're going to look at a free body diagram. But in this free body diagram, what we want to do is we want to assume that we have some type of crate. And we're going to have somebody, some stick guy, of course, he's going to be pulling on this crate because he's got a rope attached to it, and he's going to be pulling on the crate. And what we want to do is we want to look at all the forces involved in our system that are on the crate. So we're interested in the crate is our system, and we want to look at the sum of the forces on our crate. So what forces are acting on our crate? The first one, of course, we have the force of gravity pulling down. The crate also has a normal force up, and there's the force of the pull in the x from the person. Now we're going to assume in this case we'll make the clarification that the crate is being pulled on a frictionless floor, and there's no force of friction working against him, so as the guy pulls on the crate begins to move. So what we'll do is we'll sum our forces in the x and in the y. So when we look at the sum of the forces in the y, this has to equal MAY, and when we sum the forces in the x, this has to be MAX. So let's sum the forces in the y first. So when we sum the forces in the y, the sum of the forces in the y is the normal force, Fn, minus the force of gravity, and that has to equal MAY. So when we want to look at what's the acceleration in the y, we say to ourselves, well, the crate isn't burrowing into the ground, nor is it flying away up into space. So that tells us that the object isn't moving in the y. So that tells us that AY is going to be 0. So when we look, then we say that Fn minus Fg must be 0. Or in this case, Fn is equal to Fg, which equals mg. Now, let's look at the sum of the forces. So this is our first equation. And let's look at the sum of the forces in the x. So when we sum the forces in the x, we have the force of the pull, and that has to equal max. So to find the acceleration in the x, what do we say? The acceleration in the x is the force of the pull divided by the mass of the crate. So depending on how much force the stick man pulls his crate, that'll determine with what acceleration the crate experiences. Also, if the mass of the crate is large, then with the same force of the pull, the acceleration would be smaller and the crate would have a smaller increase in its velocity. But here again, we looked at summing the forces in the y, summing the forces in the x. We looked at using the idea of the equilibrium rule in the y direction because we assume the crate isn't flying away or burrowing into the ground. And that tells us that AY is 0 because in that direction we have no acceleration. But when we looked at, and that was here, the y, Fn equals Fg, which was mg. But when we looked at the sum of the forces in the x, we realized that the pull was the only force acting on the crate in the x, so that was equal to max. So that told us the acceleration in the x was the force of the pull divided by its mass.